We're going to call this pipe lesson. Today, the 4th, 01. All right, we're going to save that turd. All right, let me close this. I'm going to bring it back up. I'm going to stop the share. Oh, somebody's already recording it. Was that you, Danny?
Probably.
Yes,
Danny.
sir.
All right. Hold on.
See, you
All right,
got
well,
students that don't want to miss a damn thing you teaching.
All right. Well, if you're recording it, man, I'm gonna let it roll, and you can send it to me if there's some kind of way I can't access it. Okay.
Absolutely.
All right. Let's go back into our flash cut. Okay. Go back into our code. Okay. Now here, usually we would put the home position, and that's exactly what we're going to do, okay? But it's going to look a little bit different, okay? We have our G00. We're going to have X0. We're going to have Y0. We're going to have Z0. And we're going to have W0, okay? We need to have all those points in to zero out our to create our home position to start the pipe. What we're going to do is we're going to pick a position on the pipe, and it's going to be in the center of the pipe towards the end, and we're going to lob off the end as a test cut. Okay, so immediately following this, we're going to go right into G603, okay? Okay, we're going to turn our torch on. Okay. Now we're going to put in the same coordinates we just put in, okay? I know it doesn't seem like that makes sense, but the idea is we want to cut off the very end of the pipe to make sure that we have a nice, even, beveled spot that's straight, okay? And keep in mind, we're going to position the torch to our 0, so we might bring it in an inch from the end of the pipe, but right on the 0 spot, we want to cut this off. Okay, so we're going to put in a G01, X0, Y0. We don't have to use our Z because we already established our Z is at 0. Okay, W0. Would you guys be more comfortable if we put the Z in with every command to make it less confusing?
Yeah, don't make All
right.
It is a lot of zeros in there.
We'll keep it consistent then. Okay, we'll put in our 0. All right, we'll put in our W0. Okay, now through trial and error, I have discovered that the
the baby is 6 girls.
Your baby has 6 girls? All right.
I just walked off parole.
Nice. Congratulations. Yeah. All right.
Oh, sure.
So,
I'm sorry.
now we need to put in a speed, and I found through trial and error that 60 inches per minute is a really good speed to balance out, speed and cut quality. So our speed is going to be F60. All right. This is the only cut we're going to make, okay? But now the other thing we have to put in is our torch revolution, okay? It takes, I believe it's 40 or 41 is the number of inches that it takes for that drum to turn one full revolution, okay? So we need to put in a little bit extra because we don't want to end up having to lob off any with the cutoff wheel. So we're going to put in a G01. We need to put in a W. And we're going to put in 40.5. Okay, that'll give us an extra ½ inch to make sure that we get a full cut all the way around the pipe. All right. Now, that's your basic layout for every torch cut that we're going to do. You're going to enter your position that you're going to move to, and then you're also going to re-enter that position as your cut position, okay? So now that we're done, we're going to turn our torch off. Now we have to recenter the torch, okay? We got to raise the torch up just like we normally would. Z 0.5, okay? And hold on a minute. Hang on 1 second, guys. I gotta look at something. Okay, no, I don't. Never mind. Okay. Now, this is, it's just missing out of this code. All right. Now we have to take our W, we have to take it back to the 0 position. And this is where shit might get a little bit confusing, okay? You got to type in G00 negative W or W negative 0, okay? And what that does, okay, it's going to rotate to the right while it cuts. But in order for you to start the next cut, okay, we're at 40.5. We need to send the torch back around in the opposite direction, back to its 0 position, okay? And the only way we can do that to get it to reverse is to put in a negative, okay? And by putting a negative, it forces it to rotate to the left. And it puts it back to our 0 position, our start position. Okay. Now we're going to put in our very first pipe cut. Okay. It all depends on what size they want these. Usually they want them, they used to want them 4 inches. I think they've cut it down to 3 inches. So we are going to put in, let me just check and see where we are here. Raise the torch. Okay. We are going to put in another... we got to put in our next place that we're going to move to, okay? G00 Okay. There's not going to be any X movement at all whatsoever throughout this entire program. It's all vertical. So we're only going to use Y, okay? So we're going to do Y. Now, you remember when I told you that we lose 0.034 inches of material when we make a cut?
Yeah.
With storage. Okay. Now
Yeah,
this
I
is
remember
one.
that.
Yeah. This is one of the instances where these are practice welds, so we're not going to add the extra amount. If these were for tests, we would actually add a 0.068 to this measurement, but we're not going to worry about that because these are test plates. Okay, so our next position we're going to move to is G00, X0, Y0. You can put your Z in this line, Z0. What's happening here? Okay. Z0. W0. Okay. So that's the position it's going to move to, which we're pretty much already there. Okay. Usually we would put Z0 underneath here, but since we're going to keep the Z's all in the same line, we'll just leave the Z in the line above it, unless you guys are more comfortable doing it the way we usually do it. We take the Z out and then just drop Z back down to 0. How do you guys want to do it?
Whatever you do.
I'll tell you what, man. In order for consistency for what we've been doing, we're gonna fix this. Okay. I don't want to get you guys too confused. Okay. We'll keep 0 on a separate line. Z0. Okay, we'll bring our Z back down to 0. All right, now we're ready for the next set. Okay, gonna put in a G603. We're making another cut. Okay. Oh, I fucked up there. This is supposed to be a 3. Because we're moving 3 inches down. Okay. All right, so we do a G603. It's going to follow the same pattern. M50, G01, it's linear. Okay, it's going to be X0, Y3, and W is going to be 0. Okay. We will put our Z at 0, even though it's repetitive, just for consistency purposes. Oh, forgot to put the speed in there. 60. All right. We got our Z0. Okay, now we got to put in our pipe revolution. It's going to be G00 W 40.5. Turn our torch off. We're going to raise our torch up. We're going to recenter our W axis, G00 W -0. We're going to put in our next position, G00 X0 Y6 W0. Put our 0 back down. We're ready for the next one, G603. I'm going to save this. I want to see if it likes what we're doing. I'm getting an error in line 6. Let's see what's in line 6. I put GG03. All right. Let me see that again. Close this. Okay. You're probably not going to see too much if I was to hit play, only because everything is vertical. What we might see is it's gonna like cut here. It might move up 3 inches and cut here, and then it might move up to 6 and just stay stationary. Because the torch isn't going to move back and forth. It's going to stay in place. So if we hit play, yeah, basically it's not going to show us much of anything. Yeah, I was afraid of that. Yeah, it's not really going to show us anything. Just actually, hold on. Let's sit tight. Let's see when the W revolution gets to 40.5. Let's see if it actually does anything. Just keep your eyes on the parameters box. Okay, you can see where the torch raised. The torch is moving back to the 0 position. See it going back down. Okay, now see, now it moved up to the 3. Did everybody notice that?
Yeah.
Okay, so it is working correctly. So what's happening is we have to wait for the pipe to make the 40-inch revolution. Then it's going to raise. It's going to go back down. Well, it'll go to the next spot. The W is going to go back down. The Z should go back down. And then it moves to the next spot. Okay, so everything's working correctly. So our pipe program, it is working correctly. Okay, so we can continue on with it. So we're at 3 inches. Let's follow our pattern. we'll turn our torch on. Keyboard is fucking up on me today. All right, M51. No, I'm sorry, M50. What am I doing? M50. Okay, we're going to put in our next set of coordinates, which is going to be G00. Oh, we're already at that point. Okay, so G01, X0, Y6, W0, F60. Okay. Put our Z down to 0, even though it's repetitive. Oops. We have to put the G00 in. Sorry, I got a little bit lost there for a second. G00, Z0. Okay, we put in our G01, because this is the actually only linear thing we want to move is the pipe drum. Okay, it's going to be W 40.5. And we're done. Turn the torch off. All right. We raise the torch up. Now we got to reset the 0 on the pipe drum. G00. W -0. Okay. And then now we're going to put on our next position, which would be G00, X0, Y9, W0. Alright, we put on our G00, bring our Z back down to 0, and we're ready to cut. G603, turn on our torch. Our code is going to be G01, X0, Y9, W0, F60. We'll bring our torch back down, even though it's repetitive, we don't have to, but can't hurt to make sure that the torch is at the 0 position. And this extra line, it's not really going to hurt anything. So we bring our torch back down. We need to put in our pipe revolution. So judging from this program, the pipe revolution has been the same all the way through. What is the pipe revolution? What's the number? W what?
Negative.
No. The full revolution for the pipe, the entire revolution. To get it to cut all the way around.
40.5.
Correct, 40.5.
Right,
40.5. Right. The -0. You weren't 100% wrong with the -0. The -0 is just to turn it back the other way to reset it to the 0 position.
But 3.5
40.5 is the complete rotation of the drum.
Right.
Okay.
Right.
So now that we got that done, right. we turn our torch off, we raise our torch up. Now we have to reset it with the W -0.
But I was thinking the other day, I don't know, like, it was just some weird shit I was thinking, like, if it's all for, like, numbers to be precise, why don't we use ones in that zero column, or we would have to put another, make another place and value where the zeros is at? You know what I'm saying? Like, why is it not another number after the zero? To make it like a direct revolution, 0.5
Sorry, I can't understand because of the background static. Can you repeat that?
Never mind. Never mind.
No. It's, no, I want to hear.
You're on the train, so you won't be able to hear me anywhere.
Okay. Well, I mean, there are a couple different ways that we can do this. This is just the most general way. This is believe it or not, this is the easiest way to understand it. I know it seems like kind of a mess and there's a lot of repetition in here, but in order for us to make the software understand everything perfectly, we need to go overkill, okay? We need to put in more information than is necessary just to make sure that this software doesn't fuck anything up. So the more input we put in, the more precise it's going to be because the software is going to have all these different parameters to work with. All right, so we got our -0 to reset it. Now we put in our next set of coordinates, which is x0, and we're just going to add 3 to it, y12, w0. Okay, we're going to lower our torch back down, z00, z0. Now we're ready for the next one. Now, I only like to do 5 cuts at a time, and the reason for that is because there is a roller that sits underneath this pipe, and in order for the pipe to stay level, I constantly have to keep moving it down and putting a level on top of the pipe to make sure that this pipe hasn't moved and that it's still level. So we'll cut 5 pieces, I'll stop, I'll check everything, I'll move the guide bar that's underneath, the guide rollers, I'll move that underneath the pipe down farther to the next position, and then I'll cut 5 more pieces. Then I'll do the same thing. I'll check it, I'll move the guide bars down, the guide rollers down. I'll put the level on top. One of the most important things is you want to make sure that the pipe number 1 is as straight as you can possibly get it on this roller setup, and that the top of the pipe is as level as you can possibly get it. Because the last thing we want is for this torch to stay stationary and start cutting it cockeyed. Because then every piece that it cuts down is going to be cockeyed. We want these pieces to be as straight as possible, and it's already a little more difficult because we're cutting it at an angle, okay? And wait till you guys see all the sparks that fly out of this shit. It's crazy. All right, so let's see where we're at here. Z0, okay. We're at our last one. G603. Okay, we're going to turn our torch on, M50. We're going to put our same coordinates in, but it's going to be G01, X0, Y12, W0, I'm getting lost now. All right, we're just gonna zero our torch, just because. Now we have to put in our pipe revolutions. G00 W40.5. All right. Now that we made that revolution, turn the torch off. Okay, we're gonna raise the torch up. Very important that we raise the torch up. Z0.5. Now we send the drum in the opposite direction, W-0, to put it back in the 0 spot. Now, the reason we do this, you see this, okay, it's a perfect 40 revolutions to get to the 0 point from start to finish, okay? We actually have to go past that to make sure that the torch cuts all the way through the material. So we're a ½ inch past the 0 point. Now, that's why we put in this W0, so we can rotate it back and get it exactly back to the 0 position. That's why we do that. Okay. We put in our next set of coordinates, which is going to be our last set. G0, 0, X0, Y15, W0. Okay. We're going to lower our torch back down. And we are ready for our last cut. G603. We put in the same coordinates, G01, X0, Y15, W0. Just bring our torch back down. It's not going to hurt anything. We don't have to because it's already back down, but we don't have to. So we bring our torch back down. Now we got to put in our pipe revolution, G01. Oh, I missed a piece here. What did I just do? M51. G00. Z0.5. And enter. G00 W-0 to reset it. Okay. But instead of us going back to the home position, we're not going to do that. Okay. We're actually going to end the program right here. Can anybody think about why we're not going to go back to the home position? Just a general idea. All right. Just think about it, okay?
Because it'll get stuck.
Right.
It'll get stuck.
We got a really long pipe, okay, that we're moving down vertically. We're cutting 3 inches constantly down the length of the pipe, okay? And we've moved down 15 inches. Now, if we take this back to the 0 position, there's not going to be any material down there because we cut it off. Okay, so it's actually going to cause more harm than good in this particular situation. We take the torch back to the home position, it's going to home back to the middle of the pipe where we started in the beginning, but there's not going to be any material there. And that's going to be a huge pain in the ass because we're going to have to move the torch all the way back down there and reset everything. So if we leave it at this point, okay, our next step is we can just reload this program and run it again from where we are right here. And it'll be a lot easier to see that tomorrow. So I'm actually going to take this line out here. I'm going to save this. And we're going to save it. And yes, I want to replace it. I'm also going to save this on my USB drive in G codes. And I'm going to save it in here so I can take this flash drive to school with me tomorrow because we already have it set up. Now I'm going to close this.
We don't got to take all this shit in tomorrow. We can just put it on a flash drive.
Yep, it's on a flash drive. So it's all ready to go. That's going to save us a bunch of time. We'll just plug it in the back of my computer there, load it up, and that'll save a lot of the programming time, and we can focus more on the setup, the cuts, the angle of the torch. Because if we had to do this and all that shit, there's no way that we could fit it in the time allocation that we have. So I just want to make sure that it's on this flash drive because I don't want to get there tomorrow and have this turd not be in there. So let's go to USB drive, G codes, date modified. Here it is. Pipe lesson 1421.
So basically, like when we get out in the field, you know what I'm saying, and things gotta get done, we should be able to tell, like with these programs that we have right here that you give us, if we got these like on flash drive or something like that, is it possible like we can just plug in certain flash drive into that program and cut it?
Oh yeah, yeah. If you create a program and you save it on a flash drive, you can. I mean, as long as it's a .cnc file, you can load it in. And you can just cut it. You don't have to reprogram it.
Okay, so like I say that to say this. Like the programs that we write right now, you know what I'm saying? Like, you know, all the
You're talking about the ones that we like write in the Word documents? Like the ones I give you during like the quizzes, or the ones that I check up on you to see, you know, that kind of stuff?
Even like this one.
Yeah. Yeah. As long
like,
as
okay.
you could even go to, like, say you could go to Microsoft Word, okay?
Right.
You could type you could type just the key to that is don't put any numbers in, okay?
Just put the pattern.
But you could write the G code and save it, okay? And then we can copy it and paste it into Flash Cut, and yeah, absolutely.
That would save like all the time in the world. So we already have the G code already programmed.
Right, exactly.
So then, like, we just punch up the numbers, and like whatever the numbers is, or however long the pipe is, like, you know what I mean, the diameter of the pipe, and then like that. So like that'd be easy, right? That'd be sweet, right?
Yeah. I mean, if you think about it, this G code took us 48 minutes to write. You know,
Right, right.
that's
But
going to
if we
save us
already had a
48
G code,
minutes tomorrow.
but if we already had a G code already programmed, already knew how we was going to do it, or like if I sat down tonight and already wrote the G code, you know what I'm saying? But I gotta sit down and honestly do it. But and you write the G code, right? Exactly. The X's and the Y's, you shoot me that, and I save that, and then we figure out the dimensions. You know what I'm saying? All we had to do was plug in the numbers, so it wouldn't take that long for us when we got there, right?
Right. Exactly.
Okay. Go back.
That's one of the reasons. I mean, pipe, like you can see. I mean, in this pipe programming, like these extra zeros that we put in, like right here, where we drop the zero back down. We've already done that. We don't necessarily have to do that. We could take those out, but it's not going to hurt anything by them being in there. Like line
Like
20.
it's like a variable. It's a
Yeah,
slice shit.
but it's
You know
not
what I mean?
it's not going to hurt anything by it being in there. You know.
Yeah, but it's like a precision to the
Right.
dot type number, like a diamond cut, as you would say. Make it look real good.
Pipe, the more information we give the software, the better it's going to come out.
Right.
And that was one of the reasons that I put that flash drive in there, is so I could save this. So tomorrow, when we do this lesson, we don't have to do this all over again. You know.
Yeah. All right.
I'm going to double check with Pops and make sure that he wants them 3 inches long. But if he doesn't, the only thing we got to do is go in here and add, like, say if he wants them 4, we'll change these to 4, we'll change these to 8, we'll change these to 12. But the code's already done, and all we got to do is change the variables.
Right, depending on the diameter and the length of the pipe.
Right. Now, I've never attempted a begin grid when it comes to cutting pipe. I'm trying to think of how we would even do that. I don't know if we could.
Well, if the patterns are pretty much the same. You know what I'm saying? When you look at it, isn't it the same as in the beginning, the first 12?
The problem is there's like no X movement. So like the cut patterns, we're not really cutting columns, rows, or zigzag patterns. We're not even really doing any real cuts. We're just leaving the torch stationary. And the drum is actually what keeps the contact. As long as the torch has contact with that drum, it's going to keep cutting. But you'll see it'll shut off as soon, even like we program torch off, as soon as it loses contact with that material, it's going to shut off. And then it's going to raise up and move to the next spot. But I will bring this in with me tomorrow, and this is the program that we're actually going to use to cut this pipe. I would run it through. Oh, you know what? You guys let me miss something, man. Right here. Missed the speed.
I was just about to say that. I said it first.
I missed it right here. You know what, dude? One day I missed the speed, and I was like, for some reason, I just could not see it. and the torch was like just cutting crazy. Sparks are flying everywhere. I'm diagnosing shit. I'm checking servo motors. I'm opening up the Hypermax, trying to find out what the hell's going on. And then one of my students calls out. They're like, "Ron, you don't have a speed in there." I was like, "Oh, you gotta be kidding me, dude." I spent like almost 2 hours in diagnostic time when I just forgot to put the speed in. When you don't do that, it automatically cuts at 366 inches per minute. So that's not going to cut through anything. If anything, it's going to engrave. It's not going to cut, but it will engrave. I think one of you guys asked me once upon a time if we could do engraving on this CNC, and my original answer was no. I'm going to recant that statement. We actually could engrave on this machine. We would just have to do some trial and error and find out a speed that was fast enough that we could make all the movements, but not slow enough to where it actually cuts through all the metal. But I bet we could do engraving on this machine. I'm just now thinking about that. We're going to have to try that. When we get back to school, we're going to try that. We're going to try to do some engraving. I bet we could do it. If we raise the speed to like 120 or something like that, something that's not like crazy, like 366, but it's not quite slow enough to get through the material, we could get some consistent engraving done. That's got me interested. You know, that's what I like about this group, man. You guys think outside the box. You guys asked me that really early on, and my answer was no. And just by thinking about that error that I made with the speed, I'm going to change my answer to I think it's actually possible. I think we can engrave with this. We just have to play around with it and find the right speed.
Cool.
Yeah, we're gonna do that. We're gonna do that. All right, I'm gonna close this.
I'm getting all types of errors.
What's that?
I put the program in CNC, but I got a bunch of errors.
You put the program in just like this?
Yeah, or I believe I did.
You is there any O's instead of zeros?
Probably. It just says the specified axis has not been configured.
Oh, you know what? You have demo mode. Okay, I wasn't thinking about that. Hold on, man. Hang on, let me see if I can figure out how to correct that, because I don't know if demo mode. Hang on just a minute. Let me go into my configuration file, and let me see if I can figure out how. Okay. Hold on. Let me take a picture of this. And I'm going to show you. I don't even know if you can get into this menu, but if you can, we can try to fix this. It's probably because you don't have the W axis set up in demo mode. Hold on.
Probably. Yeah.
All right. Let's see if we can fix this together. Hang on, okay? All right. All right, I'm going to share the screen, okay?
All right.
We're going to go into Flash Cut. Okay. So you see what I'm seeing?
Yeah.
Okay. See these gears right here? It says configuration.
I'm there. Yeah.
Okay. Go into configuration. Go down to where it says drive parameters under machine.
Right.
Click on that and tell me what you have there.
There's no W.
There's no W?
Right.
Okay. Okay. Let me see.
There's no way to add it.
Do you have an icon box at the top? Let me see. Hold on. Let me see. I don't want to mess you up too bad. Hold on. Let me just try something quick. Okay, I'll tell you what. I'm gonna send you a file. Okay. And it's my setup file.
Okay.
Let me see if I can copy it. I don't know if it's gonna let me, but all right, I'm gonna try to send this to you, and when do you have a option that says load in that screen?
Where
when you're in drive parameters towards the top right, it says new load save as.
Yeah.
Do you have one that says load?
Yep.
Okay. I'm gonna send you this file, okay? And you'll probably have to save it to your C drive, but come back in here and go to load, and then load this file that I'm going to send you, okay? And then you'll get all the same parameters that I got, okay?
Sounds good to me.
All right. Get out of here. And if it doesn't work, let me know. I'll save it as another file name. And hold on, I'm going to try to send it to you right now via chat. Actually, I should probably send it to your yeah, okay. All right. Hafiz, you're asking for it?
Yeah.
Okay. All right, I'm going to send it to your Outlook, okay?
Okay.
And like I said, open up FlashCut, go to those drive parameters, go to load, and then click on that file I'm going to send you, and you should get the same parameters. But other than that, that's all I got for today, gentlemen. So I will see you tomorrow, and we'll have our morning discussion, and we'll probably talk about like the different materials, thicknesses of the pipe, different ways to set up the drum, and then we'll actually get into cutting the pipe. All right?
Cool.
All right. And Hafiz, I will shoot you over that file, man.
All right. Thank you.
All right, man. No problem. All right. I'll see you guys tomorrow.
Yeah.
That's the thing about it.